Hello, 7Es, receiving students and teachers.
Hello.
Thank you, you may sit down. All right, 7Es and receiving students, our lesson number 55 is our lesson number. All right, before we go on to our topic class, receiving students and 7Es, in our previous lesson, we looked at problem solving. Am I correct? Okay, good. We looked at problem solving, and especially in converting units, different units, or converting units in problem solving. And there was an activity which we did in our previous lesson, but I just want to emphasize what one of the students put up on the board. All right, the working out, especially with the layout, wasn't correct, okay? But the answer was correct, but it was only the layout that wasn't correct, okay? So we just go through again. All right, the question was based on this, okay? Maria entered a 10-kilometer fun run. After she has completed 9.5 kilometers, how far will Maria have to run? Now, first step, what are we supposed to do? 7Es and receiving students. What did we do in the first step? Anyone? Okay, Begley?
Convert
Okay, convert what?
kilometers to meters.
Okay, thank you, Begley. All right, firstly, you were to convert the 10 kilometers into meters. Same with 9.5 kilometers into meters. So after you had converted those kilometers into meters, you have a separate working out layout. So class, I'd like you to look up here. Okay, so firstly you convert, all right? So when you convert, 10 times 1,000 meters is equal to 10,000 meters. So that is separate. Class, are you with me? Okay. After you have done that, you also convert the next unit. 9.5 kilometers to meters. So it's 9,500 meters. Now you have a separate layout or working out. 10,000 meters, take away 9,500 meters, which is equal to 500 meters. Okay, so I'm just trying to emphasize our layout is very important, okay? It must be in order. First step, this is what you do. You have a separate working out for that. Second step, you have a separate working out and so forth. Are we clear? 7Es and receiving students? Okay, good. Now today's lesson is on measuring distances on a map, lesson number 55, receiving students. Now who'd like to tell me, on a map, what are some things that you find on a map, receiving students? 7Es. What are some of the things that you find on a map? Okay, group 1, Cullen.
Places.
Okay, good. Places. All right, anything else? Group 7, not 7, but group 8. Group 8, one from you.
Islands.
Okay, good. That covers let's say places. What else do you find on a map? Okay. Here, group 4. Sconti.
Provinces.
Okay. Thank you, Sconti. Okay, provinces, places, they all come under places. Okay, islands. Donald.
Campus, like north, east, west.
Okay, a compass, the direction. Okay, good. Okay, let's have somebody who hasn't spoken for a while. Let's have Annie.
Scale.
Okay, good. A scale. We were looking for that answer. Scale, all right? You can have scale or compass, directions. Okay, distances, we look at the scale. Okay, very important. If you look at a map, all right, in an atlas or the map in a telephone directory, there is always a scale. Now, on that scale will give you, or it will represent, the scale on your map usually represents the distance on the ground. Okay, class 70s and receiving students. Now, I'd like you to have a look up here. Okay, let's look at this example here. Map 1, receiving students and 70s. All right, on this map, you have a scale, okay? You have a scale, and this map is also found in your workbook, receiving students and 70s. Now, who can tell me, this scale here, 1 centimeter represents how many kilometers, receiving students and 70s? How many kilometers on the ground does 1 centimeter on your map represent? Win?
100 kilometers.
100 kilometers, is it correct, class? All right, looking at your scale, again, very carefully. 1 centimeter, using your ruler, 1 centimeter on your map represents 100 kilometers. Okay, so if you get your ruler, you place, where will you place your ruler? Starting at which number? 0. Okay, always, when you place a ruler, if you want to measure a distance or one point to another point, make sure you place your ruler at 0. So if you place that ruler on a scale, okay, 1 centimeter will equal to 100 kilometers. Okay, class 70s and receiving students. Okay, class, let's go through this learning activity together. Suppose 1 centimeter on the map represents 1 kilometers on the ground. Okay, it says suppose that, let's say the distance of Port Moresby to Woodlark on the map is approximately 5.5 centimeters. All right, what will be the actual distance on the ground of Port Moresby to Woodlark? Okay, suppose, okay, let's say that the distance of Port Moresby to Woodlark is approximately 5.5 centimeters. Now, again, your scale says 1 centimeter on the map represents 100 kilometers on the ground. Who can give us the actual distance on the ground of Port Moresby to Woodlark? Who can give us the actual distance on the ground of Port Moresby to Woodlark? And you explain to us, how did you get your answer? Quickly. Receiving students, what will be the actual distance on the ground of Port Moresby to Woodlark Island? Okay, Jubilee?
550 kilometers.
550 kilometers. Okay, Jubilee, how did you get 550 kilometers?
Multiply 5.5 by 100.
Okay, who agrees with his answer? Okay, you're not putting your hands up. You disagree with his answer? Okay, remember the scale, okay? 1 centimeter, let's say 1 centimeter represents 100 kilometers on the ground. So if I get my ruler and I measure Port Moresby to Woodlark, the distance on the ruler, on the map, it's 5.5 centimeters. So now I'm asking, what is the actual distance on the ground? And 1 centimeter is equal to 100 kilometers. So that means Jubilee is correct. 5.5 times 100 kilometers is equal to 550 kilometers. Class, that's the distance, the actual distance on the ground. Okay? 70s and receiving students. Okay, let's go to another example. Okay, again, suppose 1 centimeter on the map represents 1 kilometers on the ground. This time, I'm giving the actual distance on the ground of Vanimo to Arawa, which is 1,450 kilometers. What will be the distance on the map? What will be the distance on the map? Okay, the actual distance on the ground of these two places, Vanimo to Arawa, is 1,450 kilometers. Okay, let's just say, suppose that's the distance of these two places. Okay, what will be the distance on the map? What are you going to do? What operation are you going to do? Remember, 1 centimeter is equal to 100 kilometers on the ground. 1 centimeter on the map is equal to 100 kilometers on the ground. Madeline?
14.5 centimeters.
Okay, Madeline, good. How did you get 14.5 centimeters?
Divide by 100.
Okay, divide by 100. Divide what by 100?
1,450. Divide by 100.
Okay. Do you agree with Madeline's answer? 1,450 divided by 100, because the scale, remember the scale says 1 centimeter on the map represents 100 kilometers on the ground. So if we were to get the actual reading on the map, you would, 1,450 divided by 100 kilometers, which is equal to 14.5 centimeters on the map. Class 7's and receiving students? Okay, again, look at answer 1A. Okay, look at A again. 5.5 centimeters times 100 kilometers. We were looking for the actual distance on the ground. And on the map, the distance of these two places, Port Moresby to Woodlark, is 5.5 centimeters. Okay, so you look at your scale, 1 centimeter represents 100 kilometers on the ground. So 5.5 times 100 kilometers is equal to 550 kilometers. That's the actual distance on the ground. Okay, the other question was, what was the actual distance of these two places? It was already given, 1,450, and now it was asking for you to find the distance on your map. So we divided 1,450 divided by 100, which is equal to 14.5 centimeters on the map. Are we clear, 7As and receiving students? Okay, so again, looking at your map, make sure when you're measuring two places or distances, you always start at the 0 and always look at your scale. The scale will tell you the actual distance on the ground or what to calculate. Now, like I said, you can also find maps not only in your atlas, you can also find it in the telephone directory, all right? Okay, let's look at A. I'd like you to do this short exercise quickly, receiving students and 7Es. All right, you're going to measure the actual distance on the ground, receiving students, 7Es. Measure the actual distance on the ground of Port Moresby to Misima, A, and B, Kerema to Arawa, these two. Port Moresby to Misima, Kerema to Arawa. Refer to map 1, receiving students. Get the actual distance on the ground, okay? Actual distance on the ground, and then you get the measurement or the distance of those places. Use your scale. Look at your scale. Use the scale to get your distance, the actual distance on the ground of those places. Map 1 is the first map. Okay, good. All right, A. What must be to Arawa? You have to get the actual distance. All right, on the map, what is the distance on the map? How many centimeters, class? 6 centimeters. Do you agree with 6 centimeters? Receiving students? Okay, so on the map, when you measure what must be to Missima, that's 6 centimeters. Okay, starting at 0, 6 centimeters. Now, what will be the actual distance, class?
600 kilometers.
600 kilometers. Okay. Why did we get 600 kilometers? Or how? Okay, hands up. Melvin.
6 times 100.
Okay, good. Malvin, 6 times 100 kilometers. Okay, because 1 centimeter on the map represents 100 kilometers on the ground. So 6 times 100 gives you 600 kilometers. That's the actual distance of what must be to Missima. Okay, we're just saying suppose. Okay, what about Kerema to Arawa?
10.5.
What will be the distance on the map of these two places? 10.5 centimeters. 10.5 centimeters. So 10.5, what are we going to do with 10.5? Times 100 kilometers, which gives us 1,500 or 1,050? 10.5 times 100. How many places? Okay, 2 places to the right. 1, 2. 1,050 kilometers. So 70s and receiving students, please. Just make your correction. Okay, last exercise, class. Okay, for this last exercise, you will look at the other map, receiving students and 70s. The map is on, map 2 is on page 13. And you're going to answer question 1, all right? You're going to refer to map 2. Okay, this time the distance on the map is given. Class, 70s, receiving students, the distance on the map is given. You just calculate the actual distance. On the ground. Number 1, the distance on the map is given. Calculate the actual distance on the ground. Who's finished? You don't have to measure the distance on the map. I'm telling you, it's given already. You just calculate the actual distance on the ground. Class, 70s. Look at your scale. Make sure you look at your scale on map 2. Your scale on map 2 says or reads 1 centimeter on the map represents 150 kilometers on the ground. And your map, your scale, is it the same? Your scale on map 2 is different from map 1. Okay, have we finished with question 1? Yes? Okay, if you finish, hands up if you finished. Okay, let's go through question 1 together. All right, question 1, again refer to map 2 of your workbook. Now if you look at your scale, is the scale the same as the scale on map 1? No. All right, here on map 2 the scale reads 1 centimeter on the map represents how many kilometers on the ground? 150 kilometers on the ground, okay? So, the question says the measurement of those two places, Dongan to Watam Island on the map is 7.3 centimeters. What is the actual distance on the ground? What are you going to do? All right, you're going to get that distance on the map, 7.3 times 150 kilometers. Okay? So what's 150 times 7.3? Okay. 0 threes are 0, 5 threes are 15, put on 5, carry 1, 1 threes are 3, plus 1 is 4, 0 sevens, 0, 5 sevens, 35, put on 5, carry 3, 1 sevens is 7, plus 3, 10. Okay, you add 0, 5, 9, 0, 1, 1 decimal place. 1,095 kilometers. 1,095 kilometers. Hands up if you got that. 7 is Okay. Please, very good, those of you who got this. Now, 70s and receiving students, there's some activities which you will have to complete, class, some activities in your workbook that you will have to complete in your own time regarding measuring distances. Okay, we're just going to go through our summary points again, 70s and receiving students. Okay, everyone look up here, very important. When measuring distances or places on a map, always start at zero, okay? Always start at 0. The other point is use the scale, okay? Very important. You use the scale to measure the actual distance on the of the places on the ground. Okay, our key phrase for today's lesson is measuring distances. Okay, in our next lesson, lesson number 56, parts of a circle. These are the materials to bring. Round objects such as tins or coins, cardboard, scissors, compass, ropes, pencils, rulers. Okay, these are your materials to bring 70s and receiving students. And that has brought us to the end of our lesson. Class, thank you for your participation today.